Welcome to my presentation. In this presentation, I'm going to explain my project experience and work experience in data analytics and data-based marketing. Thank you for listening to this presentation. I'm confident that I will be the data analyst that you're looking for. In this presentation, I will explain when I get a business case or scenario, the kind of data analysis roadmap I would follow. Then in the second section, I will explain what data-based marketing means and what it entails. In the third section, I will explain how I do dimensional modeling and build star schema when I receive complicated data sets. And then in the last section, I will showcase some case studies and projects that I've done in my previous experience. Part 1. Building Data Analysis Roadmap. When I receive a business problem to solve and when I receive data sets, first I will think about what kind of objective I'm trying to achieve, what kind of problem I'm trying to solve. I will build a comprehensive business analysis to figure out who will read my analysis, which stakeholders are involved, and what kind of media do they have in mind to implement the data analytics with. And then I will start working on the data sets directly, building star schema to figure out the fact tables and dimension tables to measure the facts. After which, if there is multiple fact tables and multiple dimension tables to consider, I will build the bus metrics to establish correct relationships or more efficient relationships between different fact tables and dimension tables. After I build the model and after I organize and cleanse data and create more new measures in new calculating columns, then I will visualize the data, and the last step will be to build up dynamic data dashboards to convert data insights into business intelligence insights. Data-based marketing is becoming more and more popular. To determine the correct and the most efficient marketing activities in each step of the customer journey, we need to make data-driven decisions. When we have a marketing CRM system to work with, we will design customer journeys in the CRM system. For example, if we have a website, after the customer has clicked onto the product once, what action do we take? When the customer has clicked on the same product for twice, what action do we take? When the customer has added the product to the shopping cart but hasn't made the purchase, do we send the customer an email? Do we call to follow up? Do we assign the customer a dedicated agent? These are the marketing activities that we'll have to decide on. When it comes to sending marketing emails, each step on the customer journey would include received, opened, clicked, purchased. When it comes to app installment, if we have an app product, the download rate of the app, the time between the first download and the first sign up, the time between the first sign up and the first order, these are all performance metrics that we need to measure. And after the customer takes each action, what kind of corresponding marketing material, marketing activity that we're going to push to the customer has to be customized. We have to decide the frequency of us contacting customers, and when we have to decide what kind of content that we send to contact customers after they make different marketing steps. And to make these decisions, it is very important for us to derive data-driven decisions to make sure that we provide the best customer experience marketing results. When it comes to dealing with market data and customer data, the data structure is likely to follow this diagram. The raw data will be stored in the CRM systems, depending on which system the company is using, such as Pega and Salesforce, or the data will be stored in the back end of a website and call center in the sales support systems. The raw data can be stored in different forms. And after the raw data is gathered and stored in the enterprise data warehouse, normally the data engineers and developers will build multiple layers of data mart on top of the enterprise data warehouse. And BI analysts or data analysts can analyze, cleanse, and report on the data from the data mart and use the reports and business intelligence on front-end reporting to conduct different analysis such as the customer loss rate, the churn rate, to do cohort analysis, to do online transaction processing analysis, and to produce ad hoc reports. The third part of this presentation will focus on how a star schema is built when it comes to dimensional modeling. This slide shows a screenshot from Power BI when I built a star schema. When we have one fact table, we will have different columns on that fact table, and then we will have different dimensions to measure the fact table. For example, in the fact table, we have the city ID, we have the product list price, we have the product order date and payment date, the quantity sold, and we use different dimensions to measure the product sold. For example, geography is a dimension. Where were the products sold? What's the city ID? What's the continent? What's the country? And then we also have different product categories to measure what kind of product we sold. We also have dimension calendar to mention on which date was the product sold. So we have to link different dimensions to the main fact table. We can either do this with Power BI star schema model building, or we can do this with left join SQL. Fourth part of this presentation will be presenting the past case studies that I have completed. This PowerPoint slide showcases the screenshot of a dynamic data dashboard that I've built with Power BI. I was given different tables. One details product sales numbers and the order date and the payment date. Others are giving calendar dates, geographical locations, and product categories. I first decided the fact table is the product sales table. Then I've decided the rest of the tables could be dimension tables to measure sales data from different products and the quantity sold. So I first amalgamated all the fact tables together because they were given as sales data in different cities and in different continents. I first amalgamated them together, imported them into Power BI. Then I removed all the data duplicates and null data. Then I removed all the artificial calculations, because with new measures and new column, you can perform calculations with Power BI code directly on unpivoted columns in Power BI. Therefore, we didn't need the artificial calculations to mess up with our columns. And then I have imported different dimension tables into Power BI, such as geographical locations of the products sold, calendar dates, and product categories. I named them DIM products, DIM geography, and DIM calendar to let them automatically be placed together in Power BI to make the visual more concise and simple. Then I started building a star schema. I changed the column names between the tables to align with each other. For example, if in a dimension table product ID is named ID, I changed it to product ID so it can be automatically linked with the fact table when I built the star schema. Then I made sure that the relevant relationship links between different tables are activated. After I've finished dimensional modeling, then I started building different new measures and new columns to perform the calculations required by the task, such as the year-to-date sales, month-to-date sales, sales growth by different regions, and sales growth from the previous year. And after I have used Power BI code to build new measures and new columns to perform the calculations, the last step to do is to build a navigation content to build different tables to present different calculations. On top of that, to build a dynamic dashboard and data visualization. As soon as I have the new columns and the calculated measures needed, I use the new measures to build data visuals with Power BI's built-in visualization tools and to create different dynamic charts. And after creating the charts, I have also created different filters such as calendar dates, country, and product name. So on the dynamic data dashboard, we can use different geographical filters, product name filters, and time filters to see how well or how badly a product is doing in which country on which date. So by changing different filters, we can see how different products categories, how different products are doing in different regions and markets. To view my dynamic data dashboard, feel free to click onto this link. Since this is a video, I will embed the link. I will type the link out in the description box below so you can click on it and view my finished dashboard. I have also done data cleansing and visualization work in Python. First, I will read CSV and import the dataset into Python. And with different code, you can do different things. You can set index, you can remove data duplicates, you can remove null values, you can put in conditions to select data that match your specific conditions. With the right code or lines of code in Python, it's usually quite straightforward and concise to do data cleansing and large data set processing work. Afterwards, with matplotlib and Seaborn imported, with lines of code, you can usually create very appealing visual graphs very quickly. I used Python Jupyter Notebook to finish my project, which would make it easier for the project to be shared and cross-viewed amongst one team as well. Thank you for listening to my presentation. Hopefully, I have presented my skills in database marketing and in data analytics well, and I'm looking forward to hearing back from you. Thank you.